electrolysis as a general thing, yeah? Method of separating or purifying substances using electric circuits and currents. Right? So basically you're putting an electric current through the substance, and that helps separate whatever the elements are within that. All right? Now, if we take just a simple example, the best way to illustrate this, and the one that you were particularly asking about, all right? So you've got, let's say, oh, a very weird looking solution, but there you go. And we're putting electrodes, right? These are like basically wires or whatever. And you're going to have a circuit like that, right? Rough and ready, simple as that. You've done all this already, I know. The only thing that sometimes people make a mistake with, this is the positive side of the battery or the power source, and that's the negative, right? So that means the right-hand side, this thing is called an electrode, right? The one that goes into the water. Right, so these two are both electrodes, all right?
Yeah.
The negative one, all right, this particular one, is called what?
Cathode.
Yep. And the positive one?
Anode.
Anode. Good. All right. So that's the simple setup, all right? Now, what we do in here, in this solution, we've said we're going to put in sodium chloride, right? Solution. So solution is going to be aqueous. It's in water, all right? So in this, we've got sodium chloride, common salt, dissolved in the water, all right? Before going anywhere else, if we have sodium chloride aqueous solution, what ions are present in that solution?
Is it Na plus and Cl minus?
Cl minus, absolutely. And what else?
Hydrogen?
Yep, go on.
H plus?
Absolutely, good. And what's the other one?
OH minus.
OH minus, all right? The one thing that often people forget is that if you have an aqueous solution, you're going to have H pluses and OH minuses. The water, not all of it, some of it will split like that. When they split, what do we call it? There's a name for it.
When they split?
Yeah, like this. It's called dissociate. All right? Where the ions separate from each other when you put them in solution. And that's called dissociating. Right? Okay. Simple stuff. So now this is where our starting point is. We've got, in that solution, we've got two positive ions floating around and two negatives. All right? And now this is what you were asking earlier. So what happens is, we know that the cathode, and I'm going to go to red here now. So we know that the cathode, that one, all right, that's negative.
Yeah.
So the negative one is going to attract the positive ions.
Yeah.
All right. So you're going to get H plus and Na plus going towards the cathode. All right.
Yeah.
And the flip side of it, the anode, that one, is going to attract the negative ones. So you're going to get Cl minus and the OH minus heading towards the anode. All right. Okay. Now, what actually happens at each of those? All right. The cathode effectively gives electrons. All right. Shorthand for electrons. The anode will take electrons. In other words, it'll remove electrons from whatever negative ion comes here, all right?
Right.
And the cathode will give electrons to whatever positive ion comes here.
Alright.
Okay, that's the principle of electrolysis. Okay, so what actually happens now, I'll explain. First of all, the half equation. So what happens at the cathode? Oh, no, I'll go with the anode first, because I know you asked about the cathode, right? So at the anode, what happens is you've got the chlorine, two chlorine ions, let's say, for a balanced equation, come along and they give up their electrons to the anode. The anode takes their extra electrons, all right? So you end up with chlorine gas plus two electrons, all right? And this chlorine ion here is in aqueous solution,
Yeah.
okay? This thing is called an ionic half equation. All right, because all it's showing is one set of ions changing from one state to another. Okay? All right. So that's fine. There are some rules for the anode. Okay? Rule one, if there's any halide ion are displaced first. So if there are any halide ions present in the solution, they are going to come off first. All right? So displaced means they effectively are given off, right? And the gas is produced. So whether that's fluorine, chlorine, bromine, iodine, that sort of thing. Usually you're going to come across chlorine down to iodine, all right, in your particular reactions. The second one, any idea from your revision what the other one is? If there's no chloride ones or halide ones, what comes off next?
I don't know. Is it if they're more reactive?
No, no,
No, I don't.
no. Go on, go on, go on. It's on one of the pages in that red book of yours. No?
The one you don't like.
No, the one that I do like, the red one,
Oh.
not the other one. Okay, let's cut that short. I'll show you. It's going to be the hydroxides, right? They will go, if there's no halide ions present, the hydroxide will go to the anode, right? And that's going to give off oxygen gas and produce more water, right? Part of that thing you had there was 4 OH minus aqueous, right? Will give you oxygen gas. All right, to balance this, you've got to have 2H2O, and that one's liquid. All right,
Yeah.
you are expected to know that equation. Okay, so whenever you have something where there's no halide ions and whatever present, then you give off oxygen because the water itself produces. If there's no water present, so it's not an aqueous solution, all right, then it'll be any other negative ion will do the same thing. In other words, go to the anode and give up the electrons and go to its element form.
Right.
Okay.
But is he going to give it in the question if it's an aqueous solution or not?
Yes, absolutely. Right. So that'll tell you the which one of these to apply and what substance it is. All right.
Yeah.
Remember the solution, this thing, right, the sodium chloride solution, that is your electrolyte.
Yeah.
All right. So remember these names. All right.
Yeah.
Okay. And so this is the order 1, 2, and 3. Halide ions first. If not, if there's water present, then it'll be the OH minus. All right. That'll break down to give oxygen and more water. If it's not aqueous, then it'll be other negative ions, whichever one is present. All right? Fine. Any questions on that so far?
No.
No? All right. So on the cathode, in this particular example, all right, just remind ourselves, we had hydrogen ions, H plus ions, and sodium ions, Na plus ions, right? And this is the question that you actually asked earlier. What happens in this particular example is that your two H pluses go to the cathode, all right? They are given electrons by the cathode, and it produces hydrogen gas, like that, okay? Now, your question was why, all right?
Yeah.
And this is the rule, right? The less reactive positive ion is displaced. All right? So whichever one is less reactive is the one that gets kicked out of solution.
Right.
All right? Does that make sense?
Yeah.
In this case, you could also interpret it, it's exactly the same thing, but just as a reminder, the more reactive one stays in solution. So I don't mind which way you memorize it. They're both saying the same thing,
Yeah.
right? But that's why in this particular example with sodium chloride, right? Sodium isn't involved in the reactions. It's the hydrogen because sodium is more reactive than hydrogen. So the sodium stays in solution as Na plus and kicks the hydrogen out.
Oh, okay.
Okay?
Yeah.
And that's why you really need to know reactivity series. Really important. Otherwise, you'll have problem with the electrolysis questions. All right. Now, over time, what happens with this? Okay. Very simple thing. It comes up in the GCSE questions sometimes. So effectively, and I'm going to mess up my own diagram. So we've already worked out you get hydrogen gas at the cathode, and you're going to get chlorine gas in this example at the anode. All right. So effectively, we are removing the chlorine or reducing the amount of chlorine and the amount of hydrogen. Okay. So what's left, I'll use that, is that, the OH minus in this solution,
Yeah.
and the sodium. Okay. So as we keep on electrolyzing this whole mixture, this solution, okay, that mixture is going to head towards becoming sodium hydroxide. All right. So often in your exam questions, they ask you that if you carry on this process, what solution is left over? All right. That's one particular question. So say sodium hydroxide. The other thing is that remember the if we didn't have this, you'd have after a while, after you've gotten rid of all the chlorine, yeah, you'd have the water starting to break down at the anode. Okay? And a couple of years ago, one of the questions came up is that after all the chlorine's been removed, what happens to the solution? What happens is you start giving off O2, you're breaking down the OH minuses, but you're producing more water. All right. And I'll just, yeah, that's fine, it's balanced. And that actually, over time, dilutes the water. It dilutes the solution. Okay? Does that all make sense so far?
Yeah.
All right, okay. And finally, I keep talking about positive ions and negative ions, all right? Just as a last point on this, because other bits get more complicated. Yeah, that's fine. Okay, the positive ions are called what? The ones that are positive, that go to the cathode. Hint.
Medical.
Sorry?
Wait, what was the question?
The positive ions,
Yeah.
what's the name in chemistry for positive ions?
Um,
Cations.
Katana, anion,
Yep. And the negative ones,
anion.
anions. All right? You'll see that come up over and over again.
Yeah.
Okay? All right. Has that helped any? Is it like a short
Yeah, no, it has.
review?
I understand.
Yeah? Any questions? Anything else you want me to do on that?
No, I got.
Okay. Beyond that, last point to make is that you should know for your exam the required two types of electrolysis. The purification extraction
Yes.
of aluminium. Okay? I suppose I should write it fully. All right? In other words, getting pure aluminium out from the aluminium ore, all right, electrolysis is used rather than putting it in a blast furnace. Okay? And sometimes they come up with electroplating. Okay?
Sorry, I can't see.
1 second. All right. Okay. So just those two things, extraction of aluminium and electroplating. Okay. Those are add-on topics after this. Okay. And the final one is fuel cells.
Yeah.
So when we come to that, we can do separate notes on that. Okay? Any questions on this stuff that we've done today?
No, thank you.
All right, you're very welcome.